Good evening, friends, and welcome again for the virtual lab. This is the lab provided by IIT Kharagpur and many IITs, mainly IIT Kanpur and IIT Mumbai are operating this lab. Okay, and guys, now you can see the screen, and here you have to go for analog signal network and measurement lab. Just click over here. It is provided by IIT Kharagpur. Okay. Guys, you are habituated with this lab, and that's why I no need to describe all this. And yeah, just I want to go for the list of the experiment. Now you can see the list of the experiment. I am coming the C, that is measurement laboratory for UG student of EE, EC, and in means instrumentation engineering. Okay, guys, among this experiment we can perform any one, and I want to show you some physical experiment. But whenever our college will open, and today definitely it is opening day for our college, for our teacher, for few of us can go to the office. And whenever I go for the lab, I will try so that I can show some video for your laboratory. And lab experiment I will perform, and you will just join with the live, and then you can see how to perform a lab. Okay. And here is a virtual platform in which individual can perform, but here only some breach, maximum breach are available here, which are included to your syllabus, but PMMC and are others are under development process. Look, this is the development process. Okay, you can find it, but it will not show. Look, whenever I click over here, then it will show some error, and that's why we can go for the development. This find the galvan experiment. We have to perform only this experiment, which is based on generally based on breaches. Okay, so now we can start any one of this experiment. Say very easy is, that is Maxwell bridge, measurement of self inductance by the Maxwell bridge. Okay, self inductance. Now here is a theory to determine the self inductance of an unknown coil. Then we can use this Maxwell bridge. That this bridge circuit measure an inductance by comparing with the variable standard self inductance connect, connections for the connection is for the balance condition is shown in the figure. Look, here is the Maxwell bridge. Maxwell bridge deals with the self inductance. Okay, and sometimes it is asked, Maxwell bridge a AC bridge or DC bridge? Of course, because when self inductance is there, self inductance occurs due to the AC or some frequency. Okay, frequency is required. So this is deals with the AC, and this is the AC bridge. Look, this R1 and L1 is the unknown. This R1 and L1 is the unknown, and we can change only these arms, and these arms by varying this resistance R3, R4, and the self inductance of the L2, and this is the small resistance of this is the resistance of L. So R2, L2, and the this R2 is the arms resistance, and the resistance. If we change these three arms, then once we can get this millivolt. This millivolt is also uh, showing some millivolt. This millivolt will just go into the null position. At that moment, we can calculate the self-inductance. Okay, the formula is there. Self-inductance formula. L1 is the R3 by R4 into L2, and R1 is the R3 by R4 into R2 plus small r2. this is the L1 and R1. L means inductance, self-inductance of this coil, and R1 is the resistance of this coil. This is the main thing. So we can go for the experiment. Now going for the simulator. Look, here is the platform. Now just click over here. You can get this. Guys, you can find this type of platform there. Uh, Now, one by one, we can step. Look, we have to change this voltage level to the 3 volt range. Okay, because here is given, the procedures is given here. We can change this voltage 1 volt to the 3 volt range, or many, but we are using this 3 volt. And the frequency is arbitrary frequency. You may select this is 50 hertz, you may select this is 60 hertz, anyone. And this is the L1 R1. This is unknown, but why this is 1 1 is there? Because we mention the change, and we can select the core also. It may be air core or iron core also. We can use any one. Okay, and this is the variable arms. You can change over the resistance of this coil. This is R2 is the resistance of this coil. L2 is the resistance of this coil, and this is this things, and this is the R2 is the resistance of this arm. Okay, and this is the variable you can change, and this is R4. It also change. R3. This is also change. We have to make this pointer at the zero position, means null position, or we need it tends to zero position. Somehow, somewhere we could not reach the zero, and but it is tends to zero. Then we can calculate. We just come to here and set here. Then we can do this, and this is measure inductance value, and this is simulate. If we simulate, then we can get the total value. Okay, so first of all, just read out the procedure. Apply the supply voltage 3 volt from the signal generator with the arbitrary frequency. So here is the voltage is 3 volt and any arbitrary frequency. Okay, then select the type of unknown inductor core. Here is the core selection. So you can select the air core, or the air core means only coil, or iron core means there is some core, iron core is there, just like a transformer. And then switch on the supply. Here you can find the switch on the supply. And then for the air core experiment, choose the value of R2L2. Here is R2L2 and small r2. This is the arm, and another arm, this is R3 over here, this opposite to this, and R4 just opposite to the unknown resistance, unknown inductance. And from the control box below, or the directly put the values in the boxes, this respective element. Look, here you can arbitrarily select, but if you want to find attachment, you can control from here. Okay, then you can find the pointer is going to zero position. Okay, uh, then observe the multimeter pointer, it is null or closest to the null position. If null is achieved, then measure the inductor or value. Okay, tap and click over the simulation. Let's click over the simulation is not here. Measure the inductor. You have to go and then coming the simulation point. Okay, and observe the multimeter point, and if the null position is there, the measure the inductor value. Then next step, and then you click the simulation. Observe the calculated value. This is the unknown L1, and the unknown resistance of the coil R1. Okay, and then we can define the omega L by smaller, and this is the quality factor, omega L by R, and where omega is the 2 pi s. Okay, frequency is given by here. Okay, and from the core experiment, and follow the same procedure. here from step to step 6. Code experiment, if you go for the one code for air, one code for the with code, or the iron code. Okay, this is the procedure. So I am going to start. So state inductor value. Look, inductor value, it is unknown. I am selecting the iron core first. Okay, this is the iron core. My unknown coil and its resistance is unknown also. This is L1 and L2, and this is the iron core. Okay, coil is iron core. And now I have to select the voltage. Here is determined, this is 3 volt, and you put any arbitrary frequency. I say this is a 50, or you may say it is a 60. Look, you can select this is 60. I select this 60. Now switch it on. First I switch it on. Whenever I switch it on, I can see the pointer begin at the maximum point. Okay, so I can change one by one arm accordingly, so that it going to the going to the null position or the zero position. The pointer maybe come to the zero, or maybe it tends to zero. Zero is coming is very difficult. Okay, so changing, first I am changing. This is uh, this is R4. Look, nothing is changing. Okay, I am changing also this, nothing is changing. This is changing, no, nothing is changing. This is changing, nothing is changing. Now finally I am changing this. Okay, whenever you change this, nothing is happens. Again we are changing. Look, this is coming 698. So if I want to change one by one, then it may change. Now I am coming to the finally. This is R small r. Very small r2. Very small r2. I am changing over there. No, no, nothing is happening. This is only 144. Okay. Now I am changing this. No, nothing happens. Now I am changing over here. This is 2. So it should be reduced. It should be reduced. Look, this is 72.811. Okay, I am changing R4, again increasing, so I reduce it. So R2 is changing, one by changing. No, this is going to out. Okay, okay, 47. Okay, 44. Okay, 41. Okay, 36. Okay, 29. Now I am changing L2. If I change L2, nothing happens. Nothing happens. Again changing. This is 14. Look, the pointer is coming at this moment. This is 14. Okay, I am changing here. This is 3. This is 3.5. This is, oh, again change. So 3. This is 1. Again I am changing this. Look, this is tends to 0, means 1 point. Here getting 0 is very difficult. So you can see there is only 3, 3, 5, no, 19. Again bridge became disbalanced. I have to reduce it. I have to reduce it. Nothing happens. Oh, again it is 640. So first I am increasing this. Okay, I am increasing this. Then one by one I just reduce it. Look, nothing happens. So I reduce it. I reduce it. I reduce it. 1. Look, it is coming just 1.36, but it is very much difficult to reach 0, but it is nearer to 0. This is 1 point. I had to reduce some more so that first digit became 0, but it is almost impossible to make. Look, no change of pointer. 1.3 is there. I will changing. Oh, again, one small change, it causes 29. Okay, 9. I never reached this. Okay, 26. So bridge is very much tough. So first, what we do, we just increase the resistance and increase the inductance also. Okay, then one by one reduced. Or you may get this is 0 first. Okay, then switch off and switch on. Okay, then increase, then also increase, and we are one by one reducing. Look, very much reducing. Guys, you can see this is very difficult. Even in your hand, it is also difficult because look, many changes. This is, doesn't change any position of pointer. Look, here is small change. Oh, oh, again it is good. And once it is increased, it never tends to decrease. Look, 7 is almost there. We are changing so many values. Look, how many changes there, but there is none. If it is stored fluxes, so again I am going to the gym. Okay, and let's start. Now, one by one, I want to reduce it. Look, okay, just reduce it. So, guys, you can see this is 72 millivolt became static. This is the very difficulties of handling with this because self-inductance, once inductance is stored, then it will very much difficult to be. We adjust down to the 0. Now it is coming only. It is again changed up to high variable. maintain a static position. Uh, Guys, whenever this type of situation is occurred, you can see the pointer reached one point something, but now it is the pointer never go to the one point. So I am going to what happens? I am to just abruptly increase or in the highest position, everything just going to the highest position. Okay, then I say just switch off it, and I again change it, but again going to the initial position. That is three. Everything was same. Everything goes to the highest position, and just I want to switch on this. Now I one by one control this. So the because the 72 charge was stored in general case, that's why it is not changing. Just changing, just changing, just changing, just changing. R2, R2 should be changing. Now L2 should change. Nothing happens. So don't do nothing change. Just change it, just change it, change it, just change. If it is coming at the 1 to 1.36 millivolt. 1 to 1.36 millivolt. Uh, in previous step, I can reach only 1 point something. Okay, so now I want to reach this. Look, I just reduce this. What happens? Nothing changes. Once this and this, I'm reducing this. No, nothing. No, nothing is happened. So again, stop it. I'm going to reach. Okay, guys. Whenever this type of application is doing, just going to the initial switch. Okay, and again click over here. Now here code it will change to the iron core because iron core you have to perform fast because iron core store the flux. Okay, just increase the R2 and the L2 and then switch over. Look, this is coming. This is coming 72.81. Once it is stored, it gets stored. Once it is saved, and then I am going for the simulation. Guys, in this case, it is coming at least to 72, not 1. At least 1. In previous case, we have seen this is changed to 1. Now I am going for the measure the value. Now, whenever I measure the value, then I just simulate it. Whenever I simulate it, I get the value of the inductor value is 0.01 and millihenry, and resistance value is this, and the quality factor is this. So in this way we can perform this experiment. But you have seen that in the first case I am going just reach to the 1 point something value. But then once it is time delay, then it is stored the, and now it is at the 20. If you go for again change the value, it is 20. You can change it. You can change it. I am trying. You can change it. Yes. If once it is reached 20, then it becomes fixed. This is the main problem of this. This is the problem. It is its characteristic. So you have to do fast. Otherwise, it becomes static. Saturation position. So okay, whenever you come to the this position, just click simulate. You can get this hand. Okay, guys, you can perform in your own hand. Okay, guys, one by one, please perform in your own hand and show me how much accuracy you can reach. Any, all of you, only 20 or 90 students are there. Please perform in your own hand. Then our experiment will be completed. Uh, Abhishek Bharti, Anisha Kumari, Ashish Poddar, all of you, please perform it in your own hand.
Okay, sir.
Okay, only 5 or 6 minutes are there. You will just perform it or just show one by one. Okay, whatever.
सर 0.01 हो गया।